In this video we are going to talk about the water purification and our in-depth experience at CNR, Council of National Research in Bologna. This is a structure that deals with the study, research and design of new techniques and technologies in order to guarantee human and environmental health in Italy. We visited at the Technopole, a specific area at the CNR where we saw some examples of new technologies. Some of them were a device that has the ability to measure the amount of carbon dioxide present in the air inside of a room, an application that controls the status of leaches, namely the water temperature and if pollutants are present, a small robot which, programmed on a computer or remotely controlled, made a specific path within a body of water and collects water samples which are then analyzed to define its composition, organoleptic properties, and the possible presence of emerging pollutants. We also observed various experiments inside the laboratories, including a polymeric filter membrane of water made by polysulfur composite created firsthand by us. This membrane has filtering properties suitable for tap water or already pre-treated water, as it has very small pores which are therefore easily clogged. We've been told that graphene can be added to polysulfur to have a greater filtration efficiency and to counteract the presence of emerging pollutants in the water, such as lead, which cannot be removed with traditional techniques. Later, we were shown new technologies that have been developed or are still being studied that allow the monitoring of soil, air, and water matrices. We then performed other experiments to better understand the mechanism of filtration. As a first experiment, we performed an ultrafiltration of milk that has already been diluted 25 times previously in order not to clog the filter, which had very small pores. We took a syringe, aspirated the milk, and then placed it inside the filter, placed over a test tube. At the end of the operation, there was a semi-transparent liquid in the test tube, sign that the filtration had only partially taken place. With this first experience, we also learned the concept of upcycling, like taking waste to invert its use. The second experiment consisted in the ultrafiltration of a sample of water colored with rhodamine, which simulated the presence of pollutants. We previously prepared a filter, which included a filter column filled with plastic polymer, PES. After compacting the filtering layer and placing a cotton disc on top of it, we proceed with the addition at the top of the column of the sample to be filtered. At the end of the first filtration, the sample was much less colored, but not completely colorless. Therefore, we performed a series of filtration in order to obtain this last result. The last experiment allowed us to test the filtering properties of both activated carbon and graphene oxide and compare them. We took two test tubes with water samples and added a few drops of rhodamine to them. We then placed activated carbon in one test tube and graphene oxide in the other.